So the multiplication rule of probabilities is where we left off yesterday. Probability of two events, A and B, occurring is this. The probability of A and B occurring is the probability of A times the probability of B given that A occurs. So if events A and B are independent, then the rule can simply just be the probability of A times probability of B, right? So that would be the whole flipping a coin, 1 over 2, and rolling a number cube, 1 over 6, right? Probability of getting a heads and a 3 is 1 out of 12. Tails and a 3 is 1 out of 12, right? But where it changes is if we're looking at some dependent events, right? Okay, so let's look at an example. It says, 2 cards are selected without replacing the first card from a standard deck. Find the probability of selecting a king and then selecting a queen. Okay, so this is like the first one we did. Probability of a king and then, or queen, given that we get a king, right? So first is the probability of a king. And then it's going to be times the probability of a queen, given that you've gotten a king. So probability of a king is 4 out of 52. And then without replacing it, probability of a queen is 4 out of 51, which we said earlier by looking at the math was 4 out of 663. There we go. All right, number 2. It says the probability, or a coin is tossed and a die is rolled. Find the probability of tossing a heads and then rolling a 6. All right, well, the probability of a heads is 1 over 2, right? And the probability of rolling a 6 is 1 out of 6. And so we said this would be 1 out of 12. And there we go. So hopefully that wasn't too difficult. Here's a couple problems that you can try on your own as well. Now, it says the probability of a particular knee surgery successful is 0.85 or 85%. It says find the probability that 3 knee surgeries are successful. So the probability of success, and success is 0.85, right? Times 0.85 times 0.85, right? And so what I'm going to do is I'm going to go to Desmos and I'm going to figure out what this is. So we're going to say it's 0.85 times 0.85. The second surgery is successful and the third surgery is successful. And you'll notice my probability goes down to 0.61. So the probability of getting 3 successful surgeries in a row is 61%, which I guess you could say is probably pretty good. Part 2, it says find the probability that none of the 3 knee surgeries are successful. So we're going to say not, and not. So we got to think back to our complements, right? Complement would be the opposite. So if the probability of success, right, is 0.85, the probability of not success is going to be 1 minus 0.85, which is 0.15, right? So we'd say 0.15 times 0.15 times 0.15. And I multiply all those together. And again, I can do this on Desmos. And that's 0.003. So think about that. I mean, the probability of once being unsuccessful is 15%, but the probability of having 3 that are not successful in a row is 0.3%. So it's very, very low that they would all not be. Now let's do a combination of those ones. In example 3, it says find the probability that at least one of the knee surgeries is successful. So at least one. Okay, so what that means, if we're finding at least one, what we do is we take the probability of none of them being successful and finding the complement, right? So if at least one, it takes the complement of none of them. So probability of at least one is going to be 1 minus 0.003, which when we solve that is going to be 0.997. So think about that. If you if a surgeon was going to perform 3 surgeries in a row and the probability of success is 85%, if they did 3 in a row, the probability of at least one of them being successful is 99.7%. So if you and 2 other people were sitting in a room having knee surgery, you'd think it's very likely that at least one of you is going to have a successful knee surgery. Okay. Now, for this example, it says the probability of a particular rotator cuff surgery is 90%. Okay. And use that to now find the next questions that you have. All right. The last example we're going to look at. It says this: more than 15,000 U.S. medical school seniors applied for residency programs in 2009. Of those, 93 were matched with residency positions. 82% of the seniors matched with residency positions were matched with one of their top 3 choices. Medical students electronically rank their residency programs in the order of their preference, and the program directors across the U.S. do the same. The term match refers to the process where a student's preference list and a program director's preference list overlap, resulting in a placement of the student in a residency program. Okay. Now, it says, find the probability that a randomly selected senior was matched with a residency position and it was one of the senior's top 3 choices. Okay. So, the 2 numbers that we're looking at are this. Okay. 93 were matched. So, the probability of a match is 0.93. Okay. Now, the next one, 82% were matched with their top 3 choices. So, probability of top 3, so we'll just say T, is 0.882. Let's rewrite that. Okay. 0.82. Okay. Now, it says find the probability that a randomly selected senior was matched with a residency position. Okay. So that means that probability of they were matched and it was one of their 3 choices. So that would be T, right? So then we would say 0.93 and 0.82. And so we multiply those numbers, right? 0.93 times 0.82, and that's 76%. Or we'd write it as 0.76. And I'll just round to the 2 decimal places. So that's the first one. So that would be 0.76. Okay? Now, let's look at the next one. It says, find the probability that a randomly selected senior who was matched with a residency did not get matched with their top 3 choices. Okay, so think about if the probability of being matched with their top 3 is 82%, probability of not being matched is going to be 1 minus 82. Okay, so let's look at that one. Okay, so I'll write that in yellow. So the probability of being matched and not their top 3. So that's going to be 0.93 times, and the probability of not being in their top 3 would be 0.18, right? Because that's 1 minus 0.82. And so we find that, and we look right here, and we'd say 0.93 times 0.18. And that's going to be 16.74. So 0.16. There it is. So that's 0.16. So the chance of being matched but not getting one of their top 3 is only 16%. It's pretty low. All right, let's look at that one. Would it be unusual for a randomly selected senior to be matched with a residency position and that it was one of the top 3 choices? So would that be considered unusual? Well, 76% would be not unusual, right? So that would be not unusual. And remember, we think of unusual as numbers that are less than 40%. Or 50%. Well, I guess less than 40% would be as well, but generally less than 50% would be considered unusual. Okay? All right. Here's a couple problems that you can try on your own. Good luck, and let me know if you have any problems before you start your assignment. Remember, your assignment is another book assignment. and I've uploaded the PDF for those. Good luck.